Hi, I'm Jessica Califano, Director of Community Support and Publishing at Adafruit Industries. Today we're at Autodesk's Pier 9 workshop in San Francisco for episode 2 of our Women in Hardware interview series presented by Adafruit and Hackster. We're about to sit down with Heather Kerrick, Senior Research Engineer at Autodesk's Applied Research Lab, and Alex Glow, Hacker Advocate at Hackster, to talk about robotics, product design, and more. Thank you so much for sitting down with me today. So the first question that I have is for Heather. So tell us a little bit about the Autodesk Applied Research Team and how you got involved with the program.
Sure. Autodesk has a Chief Technology Officer. Jeff Kowalski is our CTO, and he has his own division, which I think is a bit novel for companies like Autodesk. So there's about 120 of us that are all kind of tasked with looking out for the future of the company. We've got 9,000 employees that all kind of keep the lights on and keep our customers cared for and address their problems today. So we have this tiny sliver of the company that focuses on what could be their problems in the future. So the Applied Research Lab is a subset of the CTO's group. And so some parts of the CTO's group will do more academic research, like designing new algorithms and everything. What we do is pretty hands-on. So we have this space, which is our lab, where we will obtain the equipment that we think is necessary for some of our what we think is going to be relevant for our customers in the future. And then we actually try making and doing stuff with it. So in a lot of ways, we're kind of like hypothetical future end users.
Cool.
So a lot of us have engineering, architecture, and design backgrounds. And so we don't make Autodesk software. We use Autodesk software or try to drive machines that doesn't have any software that really serves it. And we come up with the things that are hard for us to do, things that are easy for us to do, so that we can help inform the folks that do make our software where we think really interesting opportunity spaces are. And we definitely get a lot of empathy for our customers by the way that we work. So one big example, when we decided to do robots, like people call us the robot team, but the team existed prior to us doing our work with robotics. But we noticed that robots have been around since the 80s. It's kind of like 3D printing. They've been around for a really long time, but they're just starting to now, as sensors and computing has sort of expanded, robots are now starting to break into industries they've never been used in before. And we noticed, wait a minute, robots are definitely part of the future of how things are going to be made, and they're definitely going to be the kinds of machines that our customers are going to need to start using. And we don't really have software designed to drive robots. There's one product which will treat robots as a CNC machine, so a power mill robot. But beyond that, we don't have any sort of software to help people do assembly or pick and place. And we thought that was a big miss. If we just let that go unaddressed, as we approach the future, we won't have a way to help our customers use those kinds of machines. So we were like, okay, step one, let's buy some robots. So we started with a small tabletop robot that was in our office before we got this lab space. So it's a human safe, and we were able to do some sort of small scale experiments to help us decide, yes, we think this is worth pursuing. So we do lots of prototypes where we start small and then we'll scale larger and larger.
Right.
So we leaned into okay, we need to get some big robots. We can't fit some big robots in an office, so we probably need a facility for them. And what a lot of people that use robots today will do is, like car factories and stuff, they'll call a sort of a middleman, called an integrator. They'll say hey, we have some cars we want to build, help us get the robots that we need. And this middleman will do a lot of the kind of grunt work of speccing which robot you need, installing them. So we decided not to do that. So we bought and installed the robots ourselves. So we know all of the ways that it can be really, really painful to do that. It was hard for us to figure out billing with the robot company. It's kind of like trying to buy a car from Ford. Because we were a very unusual customer trying to buy one of a certain kind of robot. And then we had to figure out working with an electrician to get the right plug. We had to figure out how to bolt them to the ground. So it was all sorts of things that as robots move away from large factories like car factories and into people's shops or into an architecture firm, those folks will be a lot like we were as far as trying to buy them. So we really wanted to understand all of the pain points that a person trying to deal with a robot is facing, so that we could be realistic about what is easy, what's hard, and what we can expect people in the future to try to tackle.
It's really interesting how, you're basically using hardware to help develop software when, like, in reality, it's usually the opposite. So that's, like, pretty fascinating. Okay, cool. So what is your day-to-day work here like? Like, what do you do when you come in the morning with, like, your cup of coffee and there's a big robot?
There's a big robot. It varies a lot by day. Like last week, I was driving a forklift because we just got, we had two little robots that we were trading up for two bigger robots, and the robots arrived, and we needed to move them from storage here. So I'm a certified forklift driver, along with a few members on my team. So we put on our steel-toed boots and got the forklift and waved each other around. So some days I'm driving a forklift. Other days I'm drilling holes in the ground to put the robots in. Other days I'm one problem with working in like the future is you never know how to do it yet. So like I'm taking an online class about how machine learning works and how to VR.
Cool.
And then working with my team to design various demos, like what our projects are going to be. So we've got a cool project with virtual reality, machine learning, and robotics. And so like those three words is cool, but then like, okay, well, what do we do? Like, what should the robot do? And where is the person in this? So we figure out a lot of what that experience would be, what story we think it can tell, who we think it would be interesting to connect with people throughout the company, like the folks that are building our current products. Like if we think have an idea that could be useful to their customers, we can let them know, like, hey, we're up to this, and then work with them to figure out, because we sort of have the bandwidth to experiment and to fail. So it's partly our job to try something that's a terrible idea.
Right. Okay.
Drive everything to failure.
Because you don't know if it's a terrible idea until you did, and you're like, oh yeah, no, don't do that.
And you know that for every warning in the manual, there's someone who had to be
someone
like,
who did
Johnny.
Exactly.
Johnny rule, there's someone behind every one of those.
And so, but yeah, it's better for the company if 4 of us waste a month on a wild goose chase.
Right.
Than to have like a whole team get spooled up to create a product. We have 100 people across 3 countries trying to make software that's actually a terrible idea. The feedback loop isn't great. Like it takes a while before you've actually gotten far enough down that rabbit hole when you're making a real product to know like, what are we doing?
Right.
So it's in a lot of ways it's our job. If we're never wrong, we probably aren't trying crazy enough stuff. Like
you're never wrong, you aren't right.
Yeah, we're not thinking big enough. Like if everything you're doing is so obvious, then other people in the company are really well suited to do those more incremental things. Like we're supposed to be.
And it probably means that other people in other companies are already doing it too.
Yeah.
Alex, I know you've spent some time in the residency program here. Can you tell us a little bit about what you did when you were in residency here?
Cool. Well, that was definitely before the Applied Research Lab, so you have a really cool spot here, and it's exciting. I was mostly working with the 3D printers, the Connect 500 ones, which have these multiple resin options, so you can have support material that sort of peels off, and then you can also produce digital materials, which is a fusion of basically 2 different materials with entirely different properties. For example, one could be clear and flexible, while the other one is black and rigid. And I did some things melding those, for example, to create custom stamps and things. I was really interested in making like tools that I could use. Yeah. So I think a lot of the use that I got out of the Pier was enabling myself to make things afterwards. So and also to so the main project that I built was a brainwave controlled spiky mohawk that would like give you feedback on your mental state.
Cool.
With these carbon fiber spikes that would like sit up if you were alert and like chill out if you were relaxed. But the idea there is that it helps you have a feedback loop with yourself, have a sort of emotional, physical feedback loop. And there was a lot of prototyping involving like how do you make prostheses that fit your own body.
Right.
Working from photographs or physical models or whatever and putting them into Fusion 360 and playing around with them to make something that looks cool but also is totally functional and fitted. And that was really interesting.
How did you get interested in product design? What kind of sparked your interest in that field?
One of my, like when I was 5, like the job you want to be, I had a couple, but one of them was to be an inventor. So I always liked the idea of like making things. And when I was doing my undergraduate, I thought engineering was like the right thing to study to learn how to make things. And it's definitely like part of the problem. But after I graduated and worked for a little bit, I felt like I still didn't have quite the skill set that I needed. Like I understood how things came together, I understood how they worked, I know how to fix things. But a big part of making things is knowing what to make in the first place and why. And that wasn't a thing that was covered in my undergraduate. Like most of undergraduate engineering in America teaches you how to make a steam engine. Like everything you need to know to make a steam engine, which is, we could discuss like we could discuss like the future of education for preparing the next generation of workforce, but like you learn thermodynamics, you learn like how heat moves, you learn how stuff moves, but yeah, in my program, and I think it varies by school, but where I was like, I learned all of the basics of physics, but I didn't actually learn the more critical questions of like what to make. And that was where I when I was doing sort of research, I started with looking at jobs that I wanted. Like, whoa, I'm not remotely qualified for any of these jobs. Maybe I should go to school. And then found this design program, which seemed like a really good way of marrying, partly because it was an art and an engineering like kind of blend, that you could bring your like I know how things work chops, and then sort of add this human element of what people really need, and how to know that what you're making matters and you're making it the right way. And I also never like made things outside of kind of hobby in my garage. So the fact that at my grad program I could actually use like mills and like real grown-up machines seemed like a good introduction of, it's hard to design something without knowing how it will ever be made, because you can just design these impossible things. So yeah, it was back in service to 6-year-old Heather of being an inventor.
That's awesome.
There's this whole discipline now of like appropriate technologies and like making sure that what you're building is kind of in line with what humanity actually needs and suited to the communities where it's destined for. And I kind of wonder if that's part of the driving force behind the current cultural issues with Google being like, people thinking that the human element is not at all part of engineering when it so is. Like it's a huge part of the job. Like, and gender differences aside, like we can just ignore that whole question, and it's still this thing where like you need skills like that in order to build something that's the right thing.
Yeah, that actually leads me to a question that I had in here for, so it used to be that design and engineering were like two completely separate fields, but nowadays it seems like the two are becoming more and more connected. Do you think that in the future most designers will be engineers and vice versa? And where is the line between design and engineering? Is it blurry?
I think generally, if you want to discuss this question at length, go to any design school and just like buy someone a beer and just buckle up for 8 hours. Like I could talk forever about it. But I think like one thing, it gets really fuzzy with the like nomenclature. Like engineer, there's so many kinds. There's chemical engineers, there's electrical engineers, there's computer engineers. I studied mechanical engineering. There's a bunch of different kinds of engineers. There's software engineers. Like living in Silicon Valley, when people hear engineer, they assume I am,
like a developer.
Like developing software. It's like, oh no, I'm moving machines. So like I think it gets extra confusing when you have these really broad terms that can mean a lot of things to different people, where two people don't realize they're discussing two totally different jobs. And same with designer. There's like graphic designer, there's user experience designer, there's like a whole wide range of them. But I think even for like kind of all of those, you made a Venn diagram, the vast majority would have some degree of overlap. One thing that, at least my experience in school, was that design and engineering were kept pretty close together. The things, at least like the practitioners of design and engineering, often found a lot of overlap and would work together. It was the institutions that we were operating within that kept insisting on keeping us apart. So like within school, you'd have different departments, like some of the stodgy engineering professors who didn't think design was real engineering. Like it's sort of where are the engineers that are bad at math go?
Real engineering.
And then so there'd be some of that kind of dynamic going on, where like it was being imposed upon us, was like picking, choose your side. And then same with there was a lot of anxiety between like art and design, because if you're doing, and like it generally boiled down to art you do for yourself and design you do for others. And like to what extent are you a sellout? Like design is for artists who sell out. Like there's, as like, again, buy someone a beer at design school, we'll go into a bunch of detail about it, but there was like a lot of that kind of dynamic, and then you go to a company and you get put into totally different departments.
Right.
Like when a lot of products get made, there's like someone does all the engineering work to make it work, they throw it over a fence at the industrial designer who tries to make it pretty, or same with like an HVAC engineer for a building, and then the architect, and they'll have very different competing priorities and don't always have a mutual understanding of like why that pole has to go there, or why that vent has to go there, or why that thing can't be that shape. Everyone, like, I think anyone in these fields is capable of gaining the knowledge necessary to empathize with their colleague about, oh, okay, like you need this amount of stuff for ADA requirements, or oh, if you're injection molding it, it has to be this thick. Like, it's knowable, but when people are kept in separate departments, there's not a good way for that communication to happen. So I feel like it's changing in a lot of companies. They're realizing that these silos are just slowing them down and making them make like bad decisions that are way more expensive to fix later than if you could have the people together. But at least in my, like, granted, like, limited experience, the practitioners would like for those silos to be gone, but we get put in them by these larger
For
institutions.
efficiency
Companies and universities will decide that we belong in two different rooms.
Right. That actually seems like it's less efficient, actually,
I know.
if you think about it.
If you just let people talk to each other. About
Right,
what they're
right.
doing,
It seems like, you know, having a more collaborative like group seems to kind of get better results.
Well, it's something that like we're working on from a software standpoint is like with industrial designers and engineers, like they might use really different tools.
Right.
And so if you have to like transfer things in 3 different file formats,
Right.
and if you're not familiar with the tool that the person's using, like there isn't an easy way for you to make a quick edit or like talk the same language. So that's something that like Fusion 360 is trying to be better at. It's like one program, and you can interface with it in a variety of different ways. So like the person making the circuit can make the circuit in the same universe that the person doing the injection molding can make. It's the same place that the person doing the surfacing can make, and then it can be rendered in the same world.
And you can share the files between you easily.
yeah,
And
that's
so,
great,
and like we started using Slack here. Like I think there's a lot of between like the more like industry specific tools, like various CAD tools and various documentation tools, or Adobe Illustrator, like that I think there's a lot of work happening in making those more interoperable, and then like that layer of communication. So even if there isn't like a company-wide reorg, there might be ways for the folks in the different departments to chat earlier in a decision-making process, so that they're on the same, like both sides want this product to be successful, as opposed to like my idea needs to be your idea.
Okay.
And so it feels like that's kind of changing just from a corporate culture.
So what was the first product you worked on, or like your favorite?
Probably the only thing I've ever made that's like making it out into the real world. I was in a class at Stanford called Design for Extreme Affordability.
Cool.
So it's a program that's run in the D School, which is like an institute where students from all departments can all join together and do interdisciplinary projects. And so this one you would design for extreme affordability. It was basically designing for developing economies, but you had to design a product or a service, some sort of solution to a problem. Usually the solution was not what was asked for. Like once you did interviews and understood the problem, you'd realize that there was like a mismatch between what people think they needed and what would actually address their problem.
Yeah.
But it needed to be like a viable business.
Okay.
Even if it was maybe subsidized, but there had to be a way that it was affordable, but for this to be purchased by people, not necessarily given away. So there was a whole element of figuring out, import-export taxes and like a business model, like
That's tough.
who funds this, who pays for this, what's your price point. So my project was working with cocoa farmers in Cote d'Ivoire. So it's in West Africa, sort of near Ghana, and there's cocoa farmers there, and there's a whole process to producing cocoa. And one step in the process, you'll harvest these pods, so you'll have a big machete and you'll chop pods off of the trees. It's interesting with cocoa trees, they grow kind of constantly. Like at one tree, you'll have like 3 ripe pods and a bunch of underripe pods. Like the way that they're harvested, it was really interesting. Just unlike apples or something. There's seasons, but they grow different. learned something when I was there. I learned a lot of things while I was there, but that was one fun fact about cocoa trees. So you like pull off all the pods. You have this huge pile of pods, and you need to pull the beans out of the pods. So pods are these big old, about yay big. Inside the beans are kind of like, almost like corn on the cob, but like massive corn on the cob. So there's like a little stem and these big old beans that kind of spiral around the stem. And the shell, it's kind of like a walnut inside of a pumpkin. Like there's kind of like a squishy, like gourd-like wall.
Like a coconut, or no?
Like the coconuts are harder, but like so the inside, it's almost like like a thin coconut wall, and then like a squash. So there's like this fruit, kind of tough fruit, and then this hard part. So the tricky part is getting the beans out.
Right.
So folks would use machetes typically, and they'll whack at the bean with a machete enough times to both cut and crack the pod open. Then you have to pull the beans out. And so usually you use a machete to just cut the tip off, and then you have this big wad of beans. The problem though is that stem is really bad for making chocolate. If you ferment your beans with that stem in place, the chocolate's going to taste gross, and you won't get a good price for your chocolate. But it's this really time-consuming process to like weed out all of the stems. And fair trade law has made it so if you want your coffee to be fair trade coffee, you can't use a machete for this step.
Really?
Because it's too close to your hand. So there's a fear. That it could cause injuries. The problem is there's no good tool. You're not allowed to use a machete. So people use, so like the recommendation from fair trade is use a stick.
What?
Yeah,
that seems suboptimal.
Right? And so people don't really use sticks. So we designed a tool for that step of the process.
Cool.
Is it like a big nutcracker thing?
No, we tried that. That was a prototype.
I'm glad you tried it.
It's sort of like a shovel with a forked end. So it's like rounded with like a really wide, like kind of metal belly, and then a sharp edge. So you whack at the pod, use the edge to crack it open, and then the forked bit you can reach around the stem and pull the beans off. And so we designed this whole product. It's like sort of similar to machete in size. We thought we could get the price down to like a decent price. It's kind of tricky because it's a single-purpose tool, whereas machetes are used for all sorts of things. Like how can you talk someone who's really cash-strapped into spending a bunch of money on this single-purpose tool when they could be using a machete all season? So we're trying to figure out how to make it a compelling argument. But we're pretty sure that forked tip, because it can help you can get better prices for your cocoa if you ferment it better. So we thought that was a good enough value proposition. So anyhow, we present the project, and people got pretty excited about it. It's also like making a new hand tool. Like it's a kind of saturated market. So everyone was like, this looks like it could go on a farm. Like I buy this. Like this is a plausible hand tool. And so one of our advisors actually took on the project and has been producing it. So it's for sale for about $5.60 in Ghana. And I think he's got Nestle or someone partnering to help distribute it to farmers and stuff. So just kind of cool because it's actually like kind of real in the world. Like I'm not sure if cocoa farmers are making any more money. We had called it the Pelle Cobra since Cote d'Ivoire they speak French. So it's like the cobra shovel because the forked thing it kind of looked like a cobra's head. But they've renamed it the Pelle Bongo, which I think is a gazelle.
So, with like the horns.
Yeah, a lot of farming equipment it has an animal that it's named after. There's like an alligator machete and stuff. So there's sort of this trend to use animals for your branding. But yeah, so it's kind of cool.
That's amazing. That's like. That's
so I don't know how many
to see your design actually in the world helping people. Like that's I think what the goal is, right? As a designer and an engineer. So
I was like, that's cool. So I've kept in touch with the advisor that was working on it. It's been a little while since I've gotten the latest update, but I need to hit him up and be like, yo, how's the bongo doing?
All right. Well, thank you both so much for sitting down to talk with us. This has been really amazing, and we really appreciate it. So thanks.
Baller.
Thanks.
That's what I get for sitting in the middle.